Hello, welcome Board of Directors. My name is Cheryl Frederick, and today I'm going to speak with you about an innovation called virtual desktop infrastructure and how adopting this innovation will benefit our students. What is VDI? VDI stands for Virtual Desktop Infrastructure. Consider a user who is working on their computer using an application. Before the user can start the application, they have to install and configure the software. In the past, the application was made available through a disk. The disk had to be obtained from a store, received in the mail, or received from technical support. The installation and configuration process may go smoothly, or the user may encounter issues. The user would have to spend the time resolving the issues before the application was available for use. This process improved once vendors began making applications available for download from a website. The installation and configuration process was still required. Successful installation was not permanent. A new computer or a new version of the application would require another download and installation of the application. Virtual desktop infrastructure alleviates this effort on the user. Information technology students require authentic instructional experiences. There are several disciplines of IT, including software development, database administration, network administration, web development, and information security assurance. To adequately prepare a student for the workforce, authentic instructional experiences are needed that provide hands-on practice. IT students are expected to be competent practitioners when they graduate. IT degrees may have several courses requiring hands-on practice, each using a different technology. Examples are Windows Server 2012, Windows SQL Server, NetBeans Integrated Development Environment, Linux, and MySQL, to name a few. This means one student may require access to all these applications at some point in their academic program. The problem is compounded when more than one computer is required, as in the case of hands-on practice with creating a network of computers and peripheral devices. In this instructional model, all students are required to configure and maintain their own lab environments. This will be a barrier to academic progress for some students. Instead of the students spending time practicing within the lab environment, time is spent configuring the lab environment. Student success now is dependent on their ability to set up their instructional environment. Here is an example of the student's perspective in an introductory programming course that uses an integrated development tool for writing Java programs. The student has to determine which version of NetBeans to download and select the correct operating system for their computer. In addition, students will also have to make a similar selection for downloading the required programming language development kit. Each term start, instructors receive many questions from students who have difficulties installing the application. This could be due to selecting the wrong version of the application. The student does not have administrative rights to install software on their computer, or the internet download speed is insufficient and the download times out. A comparison of supporting labs for a student without VDI and with VDI illustrates the benefits. Without VDI, the student has to create a thick client. They have to install all required software on their computer. When something goes wrong during setup, the student will require support. This requires the university's technical support team and instructors to support many students. With VDI, the technical support team supports the virtual lab environment. Students just need to be provided with access to the virtual lab environment. There are a few products that support a virtual desktop infrastructure. VMware is the recommendation for our university. The upcoming slides will demonstrate that this technology has diffused successfully in multiple businesses. These links provide additional insight on the benefits of VMware. VMware was co-founded in 1998 by 5 technologists: Diane Green, Dr. Mendel Rosenblum, Scott Devine, Dr. Edward Wang, Edward Bunyan were the original co-founders of VMware. Research and development of VDI rose to the development of virtualization products and VDI. Virtualization products allow a technician to set up multiple operating systems on one computer. The one computer has virtual machines installed. One adopter of the VMware virtualization software reinvented use of the product to create point-to-point connections between a computer and a virtual machine that was running the virtualization software. This allowed them to create a virtual environment that a user on a remote computer could log into and use. This was the seed to the development of a virtual desktop infrastructure. Researchers Jerry Chen and Puneet Chawla of VMware developed the first prototype of this virtual desktop infrastructure concept, and Diane Green, also of VMware, demonstrated its potential at VMworld event in 2005. To oversee development of VDI at VMware, the VDI Alliances program was formed. There were no real issues with the development of VDI because the prototype was already tested by an early adopter through experimentation. This was done by the customer who was using VMware as a VDI. This customer was the Prudential in the United Kingdom. In 2006, VDI was officially launched into the marketplace. The intended market of VDI is any industry that had enterprise-level systems with distributed workforce or clients. This can include academic institutions with students attending school online. The student population in an online situation is distributed. There are 4 major companies that produce virtualization products. They are VMware, Citrix Systems, Microsoft, and Oracle. VMware was selected as the provider for our virtual lab solution because it has an academic program that encourages collaboration between academic institutions and the company, and there are institutions already using VDI to create hands-on lab environments for IT students. VMware markets mostly through conferences and publishing of journal articles. The VMware academic program provides exposures with university graduates with the hope that the student graduates and promotes the VMware product line. VMware also has a social media presence on Facebook, LinkedIn, and Twitter. VMware products are downloaded over the internet. This makes for easy distribution of the product. Let's look at the innovation decision process a little more. Although VMware's customer growth has been linear since 1998, educational institutions began making the decision to adopt for computer science labs in 2003, according to research done by Mock, Lee, and Tan. Their research found several successful uses of VMs, virtual machines, to support hands-on labs in information technology topics of information security, operating systems, system administration, databases, computer forensics, and networking. There are publications that explain the decision-making process and setup for each institution. These publications range in date, with the earliest in 2005. Let's look closely at the innovation timelines and some key historical dates. The innovation timeline shows the process of general public awareness of VMware virtualization products through the use of VMware's virtual desktop infrastructure by academic institutions. VMware was founded in Palo Alto, California in 1998 by 5 researchers. This is the knowledge stage of VMware virtualization products. Within a year, $1 million in booking was obtained, and shortly after, the company pierced the international market by opening a branch in the UK. By this time, companies were already persuaded and made the decision to adopt the innovation. VMware initiated an academic focus and started the academic program in 2006. Sales were so strong that the company went public in 2007. Early experimentation was done by a customer, which was Prudential in the UK. They used VMware to create a virtual desktop infrastructure. VMware researchers took this reinvention of the use of VMware virtualization product as a means to commercialize a new product, which was VDI. We have another knowledge stage in this timeline because of this. You will see that in 2008, VDI was launched, and academic institutions were already beginning to use virtualization to create a lab environment for their students. Here we can compare the S-curve against the actual adoption rate of VMware products. According to a report produced after the 15th anniversary of VMware as a company, the company gained an annual average of 33,333 customers. This chart shows the rate of customer growth since the company's inception in 1998. To put this growth into perspective, there are over 40 million virtual machines in the world. According to Diffusion researcher Everett Rogers, the adopter distribution over time follows an S-shaped curve. This chart shows the actual distribution of adopters compared to the expected S-curve if VMware had followed the normal diffusion process. Innovations do not always follow the S-curve. Rogers even cautions to, quote, not assume that an S-shaped rate of adoption is an inevitability, end quote. Disruptive technology leader Clay Christensen asserted that no single paradigm can predict the success of an innovative technology. The steepness of the adoption rate shows a linear adoption rate as reported by VMware. According to Rogers, key innovators have control of financial resources. They are venturesome and can control the introduction of a new idea into the organization. The university president ultimately controls the financial resources. He has demonstrated his quest to be innovative by seeking the counsel of disruptive innovator Clay Christensen. In fact, Dr. Christensen sits on the board of trustees. The executive director of STEM, Science, Technology, Engineering, and Math programs, oversees all information technology academic programs. She has a long history of bringing innovative technology to the curriculum and is highly regarded by the faculty. Her work experience in education provides her with the skill set to determine how to effectively implement and campaign the adoption of VDI. She is already outlining an awareness net to ensure those that need to know about the innovation will be informed. STEM full-time faculty have as much to gain by the innovation as their students. Their performance results are tied directly to student success outcomes. They are well respected by the general pool of adjunct faculty and administration. This elite team of 4 faculty members have demonstrated innovativeness. Their expertise is needed to work with the IT department to ensure a successful setup of VDI and the lab environments. To persuade the university president, a cost-benefit analysis is being prepared to show the cost savings for setting up a centralized lab that is accessed via a virtual desktop versus supplying students with software. Student retention data and pass rates demonstrate that courses with labs have the highest level of drops and the worst pass rates. Demonstration of steps the student has to take to install software in their own computer will be provided, followed by a demonstration of accessing the software through VDI. Although most faculty will be excited by the use of VDI, there will be adjunct faculty and students who will not be eager to adopt. According to Rogers, laggards can be near isolates in the organization. The adjunct faculty teach 1 or 2 courses and have almost no decision-making authority. Some of the adjuncts may view learning how to use the VDI as a decision-making authority. Some of the adjuncts may view learning how to use the VDI as extra work because they have already entrenched with using their own installed copy of the required software. Faculty may be concerned that the software on the virtual desktop may not be maintained and the latest versions not installed. Students may be reluctant to use VDI to access software because they may feel that this provides a watered-down version of the hands-on experience. Students have the option to install their own lab environments, which will address this concern. Critical mass, as defined by Rogers, occurs, in quote, at the point at which enough individuals in a system have adopted an innovation so the innovation's further rate of adoption becomes self-sustaining, end quote. There are several attributes that will be useful to helping VDI achieve critical mass in online higher education. First, before an academic institution can adopt VDI, the decision makers have to know about the innovation. There are numerous conferences and academic newsletters that inform educators. Because of student loan default, many online institutions have come under scrutiny concerning student performance. There is pressure to correct deficiencies in the system. Scholars and practitioners exist that are committed to leveraging technology to improve the instructional experience and improve graduation and retention rates. Information technology faculty and students have an interest in technology. It is a given based on their choice of career path and academic discipline. This makes this section of the educational population the perfect target to use VDI to provide hands-on labs. Finally, the current job market has been on a downturn, which means graduates have to be competitive to get that first job. Proficiency in applying information technology skills will help give these graduates an edge. As universities adopt VDI and realize improved student performance, faculty and students will demand the technology from those institutions that lag behind. Students will transfer from a school if they do not feel that the curriculum is meeting their needs. There are two approaches for diffusing VDI within an organization. A centralized approach is more top-down, and a decentralized approach spreads the innovation horizontally in a spontaneous manner. We recommend a top-down, centralized approach because we will need to secure resources to support implementation of VDI in the curriculum. We, the leaders, know about VDI and our need for consistent and reliable hands-on labs for our students. This makes the centralized approach attractive because we are actually involved in pushing technology out to those that need to adopt. VDI is a centralized concept. Software and lab resources are centralized so that remote students can access. The very nature of the innovation begs a centralized approach. Change agents are important to successful diffusion of an innovation within an organization. According to Rogers, there are seven roles of a change agent, including motivating interest in the innovation and help prevent discontinuance. Our STEM full-time faculty and the executive director are the change agents responsible for ensuring successful adoption within our university and to help effect diffusion of using VDI within information technology and computer science curriculums within higher ed. Our STEM full-time faculty are already engaged in conferences and blogs. Our institutional research board is already capable of collecting the data to show the effects that VDI has on our student satisfaction and success with courses that require hands-on labs. Once the resources are established to set up the VDI, the change agents need to identify the software that should be installed. The STEM full-time faculty will review all existing coursework and call some of the adjunct faculty to identify the software. The STEM full-time faculty will work with the IT department to create the VDI environments. As courses are developed in the future, a list of already installed software will be available to identify if reuse opportunities exist. If a new software product is needed, then the process for installing the software in the VDI will be initiated within the IT department. The most significant role the change agent will have at this time within our organization is to ensure the use of VDI is not discontinued. This will require a process for regular evaluation of all of the software installed to determine if any updates or maintenance are required. Issues with access of any software will be perceived as a barrier by students and the adjunct faculty. If issues become recurring, the students and faculty will avoid use of the VDI. Two strategies are proposed to help get VDI to reach critical mass within online education. According to Rogers, highly respected individuals that adopt the innovation can help achieve critical mass. Our university president and members of our board of trustees have shared their innovativeness in past decisions. We recommend that they present the use of VDI at a high visibility conference, presenting the past and retention rates before and after adoption of VDI to create lab activities will give the quantitative results educators need to justify adoption to their leadership team. Another strategy to reach critical mass is to use an incentive for early adoption. We recommend that our marketing department approach VMware to initiate discussion on academic partnerships that can be formed to create incentive programs. One idea is to offer free or reduced resources with the hope that graduates will promote the VMware product line. We recommend that our institution conduct and publish a case study that outlines how to implement VDI to create lab work for information technology and computer science courses. This can be packaged into a guide that can be distributed at no cost to other academic institutions. VMware has developed a strong social media following. As of August 2014, a VMware Careers Facebook page had over 33,000 likes. VMware had over 260,000 followers in LinkedIn and over 131,000 followers on Twitter. We are encouraging faculty and administration to perpetuate diffusion of the knowledge of VDI by using social media. It is important to have champions of VDI in place to ensure successful and long-term adoption at the organizational level. The role of a champion is to ensure the innovation fits within and continues to be used by the organization. The champions will own the processes and procedures for maintaining the VDI so that all software is current and aligns with the curriculum. Organizations have adopted innovations that fill the need but abandon continuous use without actually actively deciding to do so. Having a champion in place will ensure there are no gaps in its use and the university continues to expand and that the innovation isn't forgotten about as new coursework is added to the curriculum. In conclusion, adopting VDI will lead to student success. VDI is a cost-effective solution. Although some required software is free, some require licenses. Instead of needing to provide individual licenses for every IT student's computer, a pool of licenses can be purchased. Student satisfaction, retention, and pass rates will improve. Instructor satisfaction will improve because they will be able to focus on providing support for course content instead of individual technical support for a student's lab environment. In summary, the burden of creating and maintaining the lab environment is shifted from the student to the university. The student is now able to focus entirely on their coursework, and the hands-on labs are accessed through the virtual desktop infrastructure. Please feel free to contact me with questions. Thank you for listening.